Good morning, guys. Welcome to the next section. So this section is not in your textbook, but I want you to try and do it after 4.4. It talks about how to deal with solving exponential equations or solving equations where your variable is in your exponent. Next year in grade 12, you're going to learn something called logs, but until you learn that, there's a different way that will help you out with some of the stuff. So first of all, anything that would have a variable in the exponent with your equal sign would be called an exponential equation. So something like this is an example of an exponential equation. Now, how do we solve these? Couple ways. Well, the first one is if you're not in grade 11, you can guess and test, which is what you've been doing up until now. The second method, which we're going to learn this year, is learning to make the base the same, and then you can set the exponents equal to each other. There is, of course, a third method. You'll learn that next year. You need to learn something called logarithms. So when we are solving equations, if we have two statements where the base is the same in both, then you can state that your exponents are equal to each other. So if the base is the same, the exponents are also the same. And then just a little kind of piece here, just to be formal, you have to make sure that your a value is not 0, 1, or -1, otherwise that statement is not true. Example. So if we wanted to solve a couple of the equations, like the one at the beginning, if I have 2n equals 64, yep, sure you could guess and test, but you're grade 11, so let's not do that. What you want to do is find a way to write the number 64 so it is a power with a base of 2, right? The same base over here. So I could write 64 as 2 to the exponent 6. Since 2n equals 2 to the 6, n is going to equal 6. And you've basically solved for n. Okay, so set your bases the same, and then your exponents would be equal. Okay. Now, they're not always going to be that nice. Sometimes you're going to see things a little bit more complicated. An example like this one is you may have to do a little bit of work on both sides. So I've got actually this one you don't need work on both sides. Let's do that in the next one. So 2x plus 4 is equal to 8x minus 2. If I could write the 8 as a power with a base of 2, then my bases would be the same. So I can write 8 as 2 to the exponent 3. So I'm going to replace the 8 with 2 cubed. When you do that, please keep it in brackets, because you'll realize now that this x minus 2, it applies to the whole 8, which means that it is going to apply to 2 cubed. This brings you to your power rule. You're going to have to use your exponent laws. So 3 is going to be multiplied by x minus 2, which should give us 3x minus 6. Now that your bases are the same and your exponents are nicely simplified, you can set your exponents equal to each other and you can solve for x. Okay, so I'm just going to bring this down so you can see the full solution. I'm going to take this x onto the other side, so 3x minus x. I'm going to take this 6 onto the right-hand side. When you bring it over, you're going to add it. So 3x minus x is 2x, 4 plus 6 is 10. Isolate for x by bringing 2 onto the other side. 10 divided by 2 is 5, and you found the exponent that makes this statement true. If you ever wanted to check your work, take your exponent and plug it into this side, plug it into the right side, and you should see that your left side is equal to your right side, okay? So it is possible that you can check your work. Okay, last example. 9x plus 4 equals 27 to the 2x. You should notice that there is no way that I can write 9 as a power, or 27 as a power with base 9, so that the bases are the same. So in this scenario, you're going to have to change both the 27 and the 9. Both of them are powers of 3. So I can write 9 as 3 squared, and I can write 27 as 3 cubed. Okay, so 27 can't be brought down to a power 9, so we're going to try a smaller power for both. So simplify both sides. So I'm going to replace 9 with 3 squared. I'm going to replace 27 with 3 cubed. Again, I'm going to use my power rule on both sides to simplify my exponents. My exponent on this side is 2x plus 8. The exponent on the right side is 6x. Now that my bases are the same, I can focus strictly on the exponents, so it's okay to remove the bases at this point and just set the exponents equal to each other, right, because of our law up at the top. And now I solve for x. So I'm going to bring 2x onto the right-hand side, subtract them or simplify to give you 8x. That's a mistake. This should be a minus. So 6x minus 2x is 4x. And now I have to divide both sides by 4 to get the x by itself, and you should have x equals 2. Okay? Anyway, good luck. On the next slide, so there's no textbook section questions for this section. So on the next slide in the PDF, you've got 5 questions that I want you to work on. The answers are in red below. And if you are struggling and need the solutions, I've put solutions on the slide after. Okay? Good luck, everyone, and we'll see you later.